Hello everybody, we're going to be talking about a moment about a couple. This will be chapter 4.6 in your book, and we have two forces on a plane. The forces are equal, and we have a distance between them. If two forces are equal in magnitude, so if the forces are equal in magnitude, and they run parallel to each other, they cause a couple. Think of your hands on your steering wheel. You've got your steering wheel. I know you guys love my steering wheel here. And you have your hands on the steering wheel. And if you're going to turn to your left, you're going to pull down and push up with equal magnitude. That causes a couple about the center of that steering wheel. So here, how we would solve for a couple is we call it a moment. Excuse me. And this moment or couple is just going to be the force times the distance between them. So whatever the distance is between them times the moment times the force is equal to a couple. So let's take a look here. We've got two forces. We've got two forces, and I'll label them in purple. We'll say this is force 1, and this is force 2. Looking at this, if we were trying to find the couple, the resultant couple, I could redraw my beam, and I could, if this was a fixed beam here, this is a fixed beam here, my resultant couple is going to be right here. Now, the way it's rotating depends on the way the forces are rotating. So you notice this force is rotating down, this force is rotating up. So it is going to be a clockwise rotation. And what is this moment going to be on this beam? Well, this moment is going to be the force times distance 2. Now, in this case, we have to say that force 1 is equal to force 2 in order for this moment or this couple to be formed. Now this distance here, this new distance is going to be distance 1 plus half of distance 2 is where this moment would be located on the beam. Okay, so let's throw some numbers. Let's throw some numbers on this beam. I've got a beam here. I've got D1, D2. I've got my forces that are each 10 kilonewtons. So this distance here is going to be 4 meters. And this distance here is going to be 3 meters. And I've got my beam here that I've already drawn my free body diagram with. If you notice, I have my force in the Y, my force in the X, and my moment about point A. Remember, it's a fixed beam, so a fixed beam has all three of these. Well, we'll get a little bit more into that into the next chapter. So here, I want to find the reaction forces due to the couple that's created by these two forces. So the first thing I want to do is say, alright, let's go ahead and sum my moment, or let's go ahead and resolve this couple. So if I resolve this couple, I know that I have this again, AY, AX, and my moment about A, if we're calling this point A. And over here I'm going to have this couple here. And we already said that it's rotating in a clockwise rotation. And this couple is 3 meters times 10 kilonewton. So we'll call this a moment. We'll just call it moment 1. So moment 1 is going to be acting right here. So moment 1 is equal to 10 kilonewtons times this 3 meters between them, which is going to be 30 kilonewton meters. So if this is equal to 30 kilonewton meters, then if I happen to sum my moment about point A, or really any point along this beam anywhere at all, I have my moment about A, which I'm saying is positive, minus 30 kilonewton meters is equal to 0. So the moment about A to hold this beam in equilibrium would be 30 kilonewton meters. Now when you have a couple, the special thing about a couple is that if you summed your forces in the y right now, 10 kilonewtons going up minus 10 kilonewtons going down causes these to be 0. When you sum your forces in the y, if you have two forces that cause a couple, they cancel each other out. So actually AY here in this case would be 0 since there's no forces. So these two forces would cancel each other out. And there's no forces in the x, so you'd have AX would also be 0. Okay.